data files. Okay, so data files are very important and you can say vital part of your Postgre database administration. Okay, so if you understand the data files properly, sometimes it can save your life. So basically, the main intention here is to make you understand that how Postgre is going to use the data files, because people who are coming from a different other database background, they have a different ways of handling the data files. Like for example, people who are coming from Oracle side, they have a table space and they create multiple data files. Okay, these data files are basically holding the actual data. Okay, so so in Postgre, how these data files are getting handled? What is the core concept behind it? Okay, so first of all, what happens whenever we create a database? We create database. Let's suppose it's a DB01. Okay, by default, you will see multiple files are getting created, even though you have not created any table, any object on that. So these files which got created for a new database are internal. uh, First of all, when we create a new database, automatically internally Postgre is creating multiple catalog tables, multiple indexes in view to manage the database. Okay, so these files will belong to those internal objects, which can be catalog, which can be the internal architecture of your database. When I say architecture, mean to say the even the to handle the database, we need some internal catalogs, right? Or views. I will show this also practically. So this is the internal part of your files will get created on your base directory. Side by side, the moment you create any table, okay, so table related data file. So table related data files will also get created. Again, every data file normally in Postgre have two parts. Okay, one is FSM, and another one is VM files. Okay, so these two files will by default get created. VM file might not get created immediately, but FSM file, you will see what is FSM file. FSM file is nothing but free space mapping. So what happens when your data file is getting created? It's combination of multiple blocks, right? So basically, FSM gives idea to Postgre what are how much space is utilized in this particular file and how much space is left. Okay, so based on that, Postgre decides how much rows can be inserted or updated in that particular block. And VM files, the VM files are basically called as a visibility map. So visibility map is nothing but people who have read the bitmap in the engineering, they will understand this question explanation. A bitmap is nothing but a kind of small map which says that how many blocks are having the actual data and how many blocks are dead blocks or dead tuple. Okay, so basically it says this is filled block and this is empty block, something like that. So when your vacuuming process comes and it says that these many tuples are dead tuple, these many tuples are dead tuple. So in that case, what happens? It will take the vacuuming process for this particular file, okay, particular data file. So let me show you all these things practically on the screen. Okay, so let's suppose for let me drop my database which I have used for the last session. Okay, so currently we have how many databases? We have 6 databases. Okay, and let's suppose if I create a new database Let me also give you the documentation. I have created a detailed documentation for that, which I will send you after the class. So let's suppose I want to create a new database and I want to get and I will connect to that database first. Okay. So let's suppose this is my new database which I'm creating now. Create database data file underscore demo. Database is created. Does this database have any object? Does this have any object? No, does not have any object, anything, any table. Okay. But let's evaluate or let's see how the backend Postgre is handled this particular database. First, understand that. Simply, before that, let's get the OID for this particular data file. So how to get the OID? Simple command, select OID from pg underscore database where dt name equal to the database which you want to get the OID. I will explain you what is OID in a minute. So this is the OID of my database. Okay. So now to go to this particular place, which is nothing but a folder under your base location, simply, okay. So simply go to your PG data directory and base location. Base is the location where all the data files basically resides. Okay, until unless you have any further customization or automation. And now here, if we just go and try to find this particular number, you will find a folder. Can you see this? So simply do ls minus lrt. In there, we will find our database OID or database folder. So basically, let me create a relation between this. Basically, I have created a database. Internally, Postgre has allocated a OID. Okay. And using the OID, it has created a folder under the Postgre base location, first of all. So this is my folder which got created. Okay. If I go and do further cd or go in this directory and do ls, I will find multiple files. Okay. But here a question will arise. I have not created any object, but why I'm seeing these many files? So the answer is whenever we are creating a new database, finally an entity of a cluster, right? To manage the database, Postgre internally creates all these objects like meta catalog files, catalog views, and different other files to manage your entire database. Okay. And here, the moment, let's suppose currently ls minus lrt, and let's see how many files are there. So currently we have 300 files, right? The moment I will create a new object, let's suppose the moment I will create a new object, I'm going to get another file. Okay, so let me create a table. Okay, so my table is created. See this? Currently my database table is created. And let's see, and let's insert some of the rows also. Okay, so I have inserted some of the rows. Now let's find what is the OID for this particular object. OID is nothing but a identification number object identification number of that particular table. So this is my OID. So if I go to this particular database base folder, let's suppose here, and I will just simply do star and OID of the object, I will find certain files. Can you see this? And let's count the files again. We might see 306 files. So just to manage the single object, Postgre has created 6 more files. Out of 6 files, we have 2 files which is actually holding the data and metadata about the object. Okay. So simple understanding, simple logic. Postgre is managing all the data, actual data on actual core data files, and also it is managing the metadata of your database files into 2 files. One is FSM file. FSM file is nothing but it is free space map, which is actually telling that how much amount of reusable space is available inside the each data page or index page or something like that, or block. And the moment we will do first vacuuming process, automatically we will see VM file will also get created, which will tell us how many blocks in the block, how many tuples are in the block, how much is this block is dead block, or the space is can be reutilized. In other words, you can say the it is a basically a small bitmap that contains the visibility of a tuple. So basically, if your row is dead or active, if it is dead, vacuuming will go and it will create the VM file. So let me quickly show you that what I'm talking about. So now let's go to the data file demo and run vacuum full and your table name. The moment you run the vacuum full, see here, again, if you do and do T1. Okay, but why it got emptied? Select. Okay, sorry. See data file demo. Okay, now let's go and find the file again. Okay, because it was not having any data, or did we insert it? Yes, we inserted the data, right? 1 second. Employee. Okay. Select star from employee. Okay, we got the data. Okay, because we run the full vacuum, might be there was no dead tuples in the table. That's why the free space map and this got removed. Let me insert some more data and see if I get the feasibility map. Okay. One second. Let me create a table again. Okay, now let me create the table again. P. One six five eight eight. Let me insert some data. Okay, and now let's see the file again. So this time let's get the value of object OID. Okay.
Abhishek, PostgreSQL is auto commit, right? Or do
Yes,
we
it is
require?
auto commit. No, it's not required.
Okay.
Okay. So again, I got FSM file and my data file. So basically, the moment because my table is not volatile table, or there are not insert, update, and deletes are happening. That's why when I have executed vacuum, everything got wiped up. Okay, but if your table is volatile and you are doing vacuum, you will see one more file like this file called VM. Okay, so basically the main whole intention to teach you here is how to manage your data files. Okay, another important factor, let me draw this again so that I can give you clear cut understanding about that. Database, base location, your base location. Under that, you are going to get a OID for that particular database. Let's suppose this is your OID. Under that, you are going to get the object ID of that particular. Let's suppose I have created a table, right? Employee, and I got the object ID. For example, let's suppose this was my object ID. So under that, every object ID has three files. Basically, typically you will see three files. The data file, main file, then what is the extra file that you will see? FSM and VM file. Okay. One important thing to understand, the people who are coming from a different background in Oracle, when you are creating a table space and you are inserting the data in Oracle, you can manage lot of things, like you can manage the data file size, right? You can also manage auto extension. Okay, you can also manage when you will add the file, or when the next object is getting added to the data file, what will be the block size and all. Okay, but here in Postgre there is no logic like that. Whenever your data file, this file size will reach to 1 GB. Okay, 1 GB, automatically the moment 1 GB is filled, it will create another data file. Okay, for example, I have an employee table which I have just created here. Let's suppose this is my table. Okay, and in this table, in case in this table current size is 88 KB. The moment I will insert the data more than 1 GB, by default I'm going to see the extension of my file. Okay, extension will be like 1 2 3 4, like that. Okay, mean to say the same data file. For example, let's suppose if the data file, let's get the data file value first of all. So okay, this took my last, this one. Okay, let me explain you everything in detail. So let's suppose this is the OID of my table, right? And now in case if I if I insert any data more than 1 GB, by default I'm going to see another file called 16588 underscore 1 underscore 2, like that. If I insert more than, let's suppose I have inserted 5 GB of data, I'm going to see the five files, like that. Okay. So basically what I'm trying to explain here is Postgre is managing the entire database or database related things on the file level. Okay. And it is not mature like Oracle or like other databases. So they are just following the core method of it. Another important thing, someone was asked me in my last session, let's suppose I want to change this to, let's suppose Postgre is by default creating another data file whenever 1 GB of space is reached. Can we change it like Oracle? Can we change it like a White Tiger in Mongo, another thing? But here in Postgre, you cannot change your data file size. It is completely handled by Postgre itself. But in case, let's suppose if you really want to change it, you have to change the internals of Postgre. Okay. But the only problem might occur because we have already tried it. Your backup and backup utilities will not work. Okay. In that case, you have to write your own backup utility in C and C++. Okay. So this is another interview question which people normally ask. Let's suppose, uh, first of all, we understood this concept, right? If I insert the data into my table, this is my OID or the file, the main file which is holding the data of my table. If the table size is growing more than 1 GB, automatically table data files will increase, right? Like this 1, 2, 3, 4, 5, 6. So basically the question was, can I change this value? I so mean to say, if 500, let's suppose I want to change it to 500 MB. So whenever 500 MB of record is reached, I want to see another file, underscore 1, underscore 2, underscore 3. Is that can be changed? So answer is no, you can't change it on Postgre level. It is completely handled by Postgre itself. Okay. So the core concept that you have to understand is database, then database OID, and then object ID. In other words, let me explain you like this. Simply understand it like that. You have a database, then you have this database have its OID. Then again, when you create the object, it has OID. OID, the moment OID file or the OID file is created, it will create by default with two kind of files, data files and FSM file. The moment more data insertion, update and everything happens and vacuuming process runs, you will see one more file called VM file, which is going to manage your dead tuples and everything. And the data, let's suppose this particular OID belongs to employee table. And employee table is going to get more data, let's suppose more than 1 GB, then you will see one more file with the same UID making underscore 1. If you see, if you insert 2 GB of data, you will see another file like that. So Postgre manages files like that. And uh, I'll tell you one more thing because I work on the OS part also. If you run the file command of any of these files, you will see data file. If you run, see this, it is on the OS level, it is considered as a data files. Okay, makes sense?
So what about table space in this Postgres? There is table space structure also.
Yes, table space also. So same thing will happen after your base directory. Let's suppose here everything is going by default on the base. Let's suppose you have created
Mm.
your own table space. So same structure will be followed from there. Okay.
Okay, so
You will
only
you
inside the OID there is a table
Mhm.
space OID, right?
Correct. Only OID. You will see table space slash your further table space name and everything
And then inside
like
that
that.
there is a table object, index object like that.
Correct. Table object index object, and it will hold the corresponding data.
And index
Make
object
sense?
also having those files FSM and VM.
Everything. All the files
Okay.
are going to have those two kind of files. Okay. So Another important thing that you have to understand is never ever manually delete or manually handle these files. Okay, don't try to handle them manually, mean to say, until unless you have a clear cut plan, because sometimes copying these files, let's suppose you have accidentally deleted and system has created another FSM file, so you might see the conflict. Okay, so whenever you have a activity where you are moving your data from one place to another place, use certain utilities or use the database backup tools. Don't do it manually until unless you have clear cut plan or you understand what you are going to do. Okay, second thing, uh, it's not like that. Like Oracle, you will take certain bunch of data files and you can move them like that. They have transportable table space concept, right? So don't think that the same kind of tool or utilities is available here. No, it is not available. Another important thing. So when you are doing migration, you have to do migration using utilities like Aura to PG, DMS and all those things. Here we do not have any concept where I am moving my data files and I am recreating the table space using same data files. So those concepts are not exist here. They might be existing using some third party to utility, but Postgre by default does not have those kind of thing like Oracle. Okay. So
Sir, sir, I have a question.
yeah, sure.
Sir, why there was a need for creating whatever extent you are saying now after 1 GB it will create
Hmm, hmm,
another file.
hmm, hmm, hmm.
So what is it resolving purpose of split it?
Yes, yes. Let me tell you, it resolves very important purpose. So I'll tell you one thing. Basically, on the OS level, whenever certain, uh, let's suppose, let's see from the, let's forget about the database. Let's see about the, just see the normal example. You have a normal zip file, right? Your friend has sent you a zip file. If zip file size is small, what happens? Your extraction is faster, right?
Yes,
Basically, if zip file size is big, then what is happening? Extraction is further
will take
time
some time.
taking, time taking. But if you have 7-zip, let's suppose 7-zip software, and you have broke your same zip file into three pieces, three pieces, then what is happening? This particular unzip process is little bit 35 to 40% faster than normal big file. Mean to say, same 4 GB file or same 3 GB file I have divided into 1 GB 1 GB chunk. So
Okay.
on the system level, handling multiple files for the same source, it is very easy. Now you will ask why. So if the file is single file, always applying a process or CPU to the single file is just limited. Okay, or it depends on the utility. Let's suppose I want to apply the parallelism. Okay, I want these three files to be handled by a different process, then it will be very easy. But handling a single file might be cumbersome sometimes. Okay, another thing from the database point of view, database, if you have a single file, okay, single file is nothing but first of all, file means what? Combination of blocks, right?
Yes,
Yes or no?
yes,
Okay,
yes.
so let's suppose you have a small room versus you have a big room. Okay, just think from the lookup point of view. Lookup is nothing but your select point of view. So when you have a big file and you have to look up the data, you have to scan multiple blocks, right? If you have a big file, your scanning will be higher. Okay, second thing, if your files are divided into chunks and every file header is updated with the information, then the whole scanning process will be very easy, right? Rather than scanning this 5,000 square feet house versus scanning the small room will be easy, right?
Yes.
So basically, from the database point of view, let's understand like that. If this room, I have a big plot, I have divided this plot into multiple rooms. And every room on the gate itself, if I have written what is residing inside the room, let's suppose I will say this room is dedicated to food related items. So I will make it kitchen, and in the door itself, I will say in this room I have vegetables, I have spices, I have equipments to make the food. This room is kids room. I have these many items inside under my room. Every room door is having a small paper, and paper have the list. Okay, so what will happen if you are looking up some stuff, will it make easy or hard? It will be very easy, right? You will simply go and read the note which is pasted on top of the door, and you will say, okay, I should not be scanning this room because I don't want that particular stuff that I'm looking for. I won't scan this room. Finally you found your stuff here. Let's suppose you are finding your bike key. So how you find your bike key? Basically, what is the main purpose, or what is the main way of or the method that we have used? We have used the header of the data file block. Basically, rather than going into all the rooms, we have just simply read the block of the block header of my data file. Okay, now let's take the another example where I have kept my stuff into a 5,000 square feet room, but I have not classified them. I have created a big list here. Same 5,000 square feet room, only one door, and on top of my door, I have just created a big list. Previously, normally in the single room, I used to get list of like 100 items or 50 items, but in this big plot on the big room, I have created a list of, let's suppose, 4,000 stuffs. So now again, this is scenario A, this is scenario B. When you will come, first of all, to scan your header itself will take long time, right? Yes or no?
Yes.
Right? First of all, you will scan full list. Then you will find, okay, boss, out of 4 after scanning. And another thing, scanning means what? What I am wasting here?
My resources, my CPU
Your
and memory, I
CPU,
think.
memory, everything you are wasting. And finally, after scanning this much big room, you identified that my block is here. But simultaneously, if the same process is getting into the chunks, will it be easy, right? Are you getting
Sir,
this example?
sir, for those chunks also, I have to navigate now. See, we have divided that file into
Mm-hmm.
sub parts like 1, 2, 3.
Mm,
So whatever I am trying to find out or trying to look for
mm-hmm.
that also I have to look around the header for those files.
But to find those many files, to scan those many records, you have to go to the a big file. Scanning a big file is always resource consuming rather than scanning the multiple files. And you can also do it parallelly. Okay, in this case, you have to do everything sequentially. So that is another thing which you can use.
Okay.
Getting my point? So whenever you are doing things parallelly on on OS level, it is always faster than going sequentially. That's why if you further read on the databases, we will find indexing. So here what we did, our index size itself is very big. To read my index itself, I have applied lot of resources, and after reading my whole index file or whole data header file, I identified that my key is on this particular space. Okay, but rather than here, what I will do, I can if I have multiple processes, let's suppose I have allocated 3 processes, then I can finish these 3 rows faster than this particular process where I'm going sequentially. So that's why databases are, whenever they create the data files, they try to create the data files on multiple files. First of all, accessibility is fine. Accessibility is very easy. File handling is also very easy when you have multiple chunks, and also metadata distribution is also very easy rather than putting into a single file. Another very important thing, which is, I don't know you people know or not, there is a concept called checksum. How many of you know about the checksum? So checksum, anyone know about checksum?
It will verify whether
Yeah.
the bits
Yes.
are correct.
Yeah.
Correct. So basically, checksum is a algorithm, or checksum is I would say program, utility, or whatever you want to say. It basically goes and check whatever database or data block or data information that I have stored in the block, it is retrievable or not at any point of time. If my checksum, always in the data file header, there's a small part, 2 KB part, which dedicated to checksum. So if my checksum says this particular block is corrupted, or basically in the every checksum I have two values, start and end. So start and end values are not matching, it means my block is corrupted. So checksum, doing the checksum kind of thing on a big file or big chunk is always a lengthy process. Whether it is managing on the small files are very easy. Okay. And further, when you will understand about the concept of compress and decompress, then you will understand that compressing a big file and decompressing a big file is always resource consuming. That's why we are making the data files into pieces. Make sense? This justification,
Hmm. So,
Dipender?
sir, is it like partitioning? Because
Basically, it
uh,
is a partitioning only, so that when I am retrieving my data, it's supposed to be fast.
okay. So, like this is actual concept of partitioning, or like partitioning is somewhat different.
Something different, but just to make you understand this specific thing, you can say it's a partitioning.
Okay, sir.
So this is just a concept of data retrieval, compression, checksum. There are a lot of terminology involved, and finally you will understand that the managing small chunk of files are always easier than managing a big file. Okay,
And
let's go to
sir,
the,
can
yeah.
one
Mhm,
point. So what is the page structure? Like in a Oracle is a block, right? So in Post is a
mhm.
page, right? So what
Correct,
exactly contain like a header and
correct.
again items and
Yes.
address? So what is
Let
that exactly?
Yes, my next topic is related to SAM only, because I'm going to talk about toast in my next topic. Okay. So
Okay.
before I go to toast, any question? Meanwhile, I'm finding my documentation. Any doubt? Anything? It's a
Abhishek,
very small concept. You have to just simply understand it. It's not that very important or something. But as your DBA, we should understand about this specific concept. Yeah, tell me.
yeah, Abhishek.
Yeah,
Am I audible?
yeah, you are audible.
Okay. So we just discussed about FSM and visibility map.
Correct.
So so whenever we create a table or any object,
Mm-hmm.
so Postgres creates one data file and two other file called FSM and visibility map.
Visibility
So
map.
FSM comes into picture whenever whenever we insert the data, correct?
Correct.
Whenever we do insert operation, so Postgres will check the FSM file where the free space information is available, correct?
Correct.
So whenever we do select and
Uh-huh.
update or delete,
Mm-hmm.
in that case, visibility map comes into picture because
Correct.
Postgres has to check where is that data is
Whether
located.
it is whether it where it has to be located, and whether the availability of the space is available or not. I have created a very good map also in my documentation. Just see this.
Okay.
This document I'm going to
So
send you with the practice and everything. Yes.
Okay. So whenever we perform a vacuum operation,
Mhm,
so vacuum reads this visibility map file, and
mhm.
where he finds the information about the dead rows or whatever the
Correct.
rows which is marked as a dead, then
I
it
did.
goes to that location and do the cleanup.
Yes. If it doesn't find, it won't go to that object.
Hmm.
That data it will.
So now when you run the vacuum full operation on that table,
Mm.
so that FSM file got removed.
Removed and VM file
So
also got removed.
VM file was not created
Yes.
because I think we didn't
Never did
perform
any
select,
insert,
update,
update,
delete.
alert, or any. Yes. Yes.
Yeah, but I'm still not clear, like when we run a vacuum full, why that
Mhm.
FSM file got removed.
That's what I. It's supposed to create
So
the VM file.
is it like that there was no dead rows in that table, or
Might be.
so
Might be. But technically,
okay.
based on the thing, it's whenever in the real-time production environment, whenever you run the vacuum full or something, you will see a VM file created. In our environment, just forget about it. It's just a plain environment. But in the real time, you will see one visibility map file got created with the details. Another thing, if you people want to understand it more, let's suppose you got some kind of issues or something where you have to understand your files and all. So there's an extension also, PG inspect, and it gives very clear cut information. What is happening inside your object? Let's suppose it shows you the hidden column of your tables, which is managed by table. But very important thing, this has happened multiple times. Do not handle any metadata information by yourself. Even though you are getting the data using this extension, do not change anything. I have written also here somewhere in the red. Just see your object, evaluate your object, but don't change it until unless you know your Postgre program, C++ programming and all. It is just to see the pages header or the what is lying inside your table. Okay, but don't change it manually. Okay, make sense? This is the extension you can also use to go further inside. I have not shown this particular thing, but I have mentioned in my documentation. If you want to go further seeing what is going inside your uh, basically data files.
Abhishek,
Make sense? Yeah.
yeah, Abhishek, sorry, I missed a few things in between.
Mhm.
So this is the document which you will be sharing us. This is what is
Yes. This is the today's document. But what I was talking about, I have mentioned everything here.
okay.
See, everything is there, and you have to run the same thing in your environment and
Okay.
get the concept. Even I have given the some extra information also here. I have also given you an extension which you can try to understand what is goes inside the your block and header and everything. Okay.
Sir, one question. So
Mhm.
when you create the table, so those files are automatically generated, FM and VMS, or
Mhm. No, first
while
FSM file will get generated. VM
okay,
file will
FS,
not get generated.
free,
Only
okay,
FSM, because FSM
uh,
is going to show you same concept header. What is lying
hmm,
inside here? Can my room take further stuff to keep it, or
oh,
room is
okay,
already full like that? Okay. Visibility. See, FSM is basically OS concept. If you people have written the book of I don't know in Madhya Pradesh, they normally teach this operating system in the first semester. So there you will find the visibility map. Basically, it's a OS concept. I'll send you the book name also. You can get a very good detail there. But don't read it. Read that book wearing database administrators goggle. Okay. Otherwise, you
hmm,
will get confused. Only read it from the OS point of view. Okay. Can I go to the
uh,
next topic?
yeah.
Anyone else? Any more question? Okay.
Yes, I have one more question.
Yeah. Tell me.
So, like, we know that whenever we run a vacuum full operation, so
Mm-hmm.
Postgres internally drops that
Mm-hmm.
table, recreates that table, and sequentially it inserts all the row and
Mm-hmm.
reclaiming the space.
Correct.
So when this operation done in the background, Does the OID of that table changed or it remains the same?
I think it will remain the same. It won't change.
Okay.
That will remain same. It will not change. Okay. Another important concept. Normally, it's important, but not that important. But I have seen interviewer, they always ask about toast and toast related stuff. Okay. First of all, Vikas, are you clear, right? Can I go ahead, right?
Yes, yes.
Okay. So there's another concept called toast in Postgre. Okay. It's not very important thing or something, but as we are talking about all these things, let's understand about toast also. Okay. So Postgre, first of all, how Oracle manages the large objects. Let's suppose I want to, I'm making a YouTube and I want to store MP3, MP4 or big images. How I'll do it in Oracle?
It put the data inside the table space somewhere else. It is not intact with the table.
Blob.
Only the
Blob.
pointer will be, yeah.
Uses blob.
In DB2, that is the case. It uses blob, and the blob will be residing inside the table space.
Very good. So same thing happens in Oracle. Oracle also have multiple data types, which is handling, which is basically storing the large objects. Okay, but here in Postgre, it is a bit different. Okay, it's a bit different. First of all, let's understand the some core concept. Okay, let me recreate this. So first of all, we have, let's suppose we have 8 KB of block size. Okay, initial is 8 KB. Okay, in the 8 KB block size, how Postgre is going to handle the data? Basically, it will try to handle the data on 2 KB. Okay, it has written the data of 2 KB, 2 KB, 2 KB, 2 KB like that. Basically, I have 4 rows in my single data block. The moment something comes which cannot handle this 2 KB limit, what Postgre is going to do? Either it will try to compress it, okay, or it is going to allocate a new block. Okay, that is a traditional way of handling the things, right? Traditionally it happens, right? If I'm not able to hold it, I'll just do, I'll create a new block. That is nothing but block migration, block chaining, all those concepts. But here in Postgre, what happens when your objects or your data is oversized and it is storing the values like text, byte or JSONB kind of thing, automatically Oracle Postgre is creating the toast object. Mean to say, these particular for this example, just see, I have a big text, right? Really long string. It's more than a small novel, ATC, something like that actually. So basically, this long text is not getting accommodated by a single block. So what Postgre is doing, Postgre is distributing that particular long object blocks. Basically, Toast is trying to handle the initial data into 8 KB block. But in the case if the particular object is a big object or it is not able to accommodate in the block, it will try to compress it first. Okay, so let's suppose if this block is toast block, it will try to compress it. If compression first thing is compression. Let's suppose I have inserted 1 to 1000 rows. It will try to compress and hold it. Let's suppose 1000 to 5000 rows I have inserted. Again, it will try to compress. The moment it sees, the algorithm will see that further compression is not at all possible. It will straightforward create a toast table. And toast tables are nothing but, here in this block, they will just put a small marker, and this marker is going to mark to this particular toast table. Okay. And this toast table is going to hold my actual data, which is coming from a specific data types. Okay. So let's suppose if my data type is not uh, uh, the kind of data type which holds very large values, then it will get accommodated in the same object or block. If Postgre is not able to handle that particular data type, like in Oracle blob or something like that, so automatically Postgre is going to create a toast object for that. And these particular pages or table is going to having the reference of my toast table. So whenever you are doing select star from my table, automatically internally you are getting the data from these toast tables. So in other words, you can say this is nothing but sharding kind of concept, where I have shard my data into multiple pieces, into multiple nodes, something like that. Okay. So to understand the toast concept, first of all, you have to understand the concept of data types. So which particular data types are toast enabled and which particular data types are non-toast enabled. So mean to say, so let me quickly fetch a table from internet. Toast enabled data types. Now, some of the people might asking like why we are talking about toast. We are a DBA, right? And all these concepts are the development related concept, right? I have seen the way sometimes toast has been created or toast has been done is, it's not, I would say it's not done properly by from the development team. And if you're doing a performance tuning, and if you understand about your toast objects, it will always give you a lot of room for doing the performance tuning. So let's understand. Let me show you this small table which will tell you that which particular data types are toast enabled and which data types are not toast enabled. So for this, which one should I pick? I used to have a very good diagram, but currently I'm not able to find it. Let me
Abhishek?
find Yeah.
So question here is that the toast mechanism, right?
Mhm.
This is Postgres internal mechanism or it
This
has
is
been it
Postgres
has to be.
internal mechanism. Yes.
So how is the developer involved here?
So basically, developers sometimes what they do, they are using a lot of data types. They are creating a lot of toast tables. Okay. And toast tables are nothing but, it is going to give you trouble when you are running the big vacuum process. Okay. In case if you have a lot of toast tables, your vacuuming might take long time. Second thing,
So a
sometimes,
developer, sorry, so a developer can also create a toast table by itself, by himself.
no, they can't create. Everything is managed by Postgre itself. I will practically
So,
show you.
this is only for all sales, right? If that size of that table or block is now accommodated, then it's going to create, right? Those table
Correct. That's all.
for that
That's all.
data. Okay.
For that particular thing, and it is going to be handled in the toast tables. Okay. And being a
Understood.
DBA, you should understand about all these concepts. Okay. Otherwise, what will happen? Let's suppose if any performance issue comes, let me create and I will show you.
Just
Create
like a row chaining, row migration in Oracle, right?
row creation, correct. The same concept, but it is very important. If someone asks you and say, okay, evaluate my database and tell me what can be done. Okay.
Hmm.
Okay. Okay, so create table test db01. Let's take 2, 5. Connect to test db05. Connected. I don't have any object /tt. Let's create my object. I'm taking intentionally, I'm taking this data type, okay, just to show you the toast. So my table is created. Now, the moment I will put the data, the moment I will put the thing, you will automatically see that toast is getting created. Okay. So now let's first. Can you see here? For my table, already toast table has created. Why it got created? Because by default, the kind of data types I'm taking, Postgre internally says it is toast enabled data types. So there is a detailed table available in the documentation, which says that which particular data types is toast enabled and which is not toast enabled. Okay. So currently, if you simply go and do select count star of your table, select count star of your this toast table, you won't find any data. Why there's no data? Because still toasting is not started. Basically, let me add some data to my first table. Let me add. Okay, I have inserted the row. Select count star from. I have one row. Let's see our toast table. 0. No toasting happened. Still my blocks can accommodate the space. Still my blocks are capable to take more data. Okay. Also check the length, because length is also very important. Length of my table, what is actually stored. So can you see this? Currently, my length is only 10 and stored length is 11 and ID is only 10. Okay, let's do one practical. And let's check the toast also. 0, no rows. Now let's insert some further more data. Now I'm adding 40,000 records. So 40,000 record toast will happen. Blocks will get toasted. Anyone want to try? I have added 1 to 1000 rows. Now I am adding few more rows.
Yes.
So let me add it. How many records I have on my table? I have select count star from. Two records. Let's check the data length also.
Abhishek,
Yeah.
can you just run select star from table name? I want to see the data.
From. Basically, I have just inserted the
Expand the
data.
display.
Huh?
Expand the display that /x.
Yes.
Now, okay.
In my row itself, I'm adding more values just to show you. Because otherwise I don't have any ways to show you practically. Otherwise, until unless it's a production application. Makes
Abhishek,
sense,
can
right?
you please, yeah.
Yeah.
Abhishek, can you please describe the table?
Yes. Oh. So I am adding more and more space to my rows basically. I'm adding more rows
Okay.
to my
You are adding for the paper text column. You are adding for
adding
the
more
data type.
rows, more rows. So that I can reach to a limit where toast will happen to my database, and practically I can show you, because this is what happens actually in the production. It will happen for which case? Can someone tell me the real time case? In which kind of scenario this
Uh,
thing happens? Any
if the
use case?
application is, yeah, let's suppose if you have, in my example,
Uh-huh.
the application is uploading the image file, PDF
Very
file,
good. Hmm.
CSV
Hmm.
file, you know,
Very good.
so that all stuff comes into
Comes into the
this.
picture. And let's suppose I'm a
Yeah,
YouTuber. I'm
yeah,
my application is YouTube. Can I block my user saying that boss don't upload it or don't? Because just I have created the environment itself or application itself to upload the data, right? But
yes,
in the backend, how my database is going to manage, that is very important for DBA to understand. Otherwise, there will be a lot of performance issues, which you will think it's just indexing. Someone will say, "Oh, my IO is slow. Let's bring big higher disk to fix the issue." But but the more you understand your code, the more you understand your table or things. I'm not telling it is only 100%, but 10 to 15% can be resolved by your internal Postgre architecture also, if you understand it better. Now let's go to our main topic again. Now let's insert further more records. Now data length, let's check the data length quickly. Let me do X of. So data length is 40. Now let's add further more. I'm adding 40. I don't know if my database will able to handle it or not, but let's do it. Okay. Now let's understand the data length. Now what will happen? Toast will happen, right? Now this is compressed. Initially, how much record I have inserted? 40,000. Okay, compressed, able to handle. But this time it will not do. It will do where? Where it will go? What will happen? It will
Toast table.
automatically go to toast table. So how to check the toast table? Where's my toast table? Oh, make sense? I got the record in my toast table right now. And what is my toast table? We just did it on top. Or let's take it from my documentation also. I know it will be little difficult for everyone to understand today, but if you read it more and more, you will understand toasting also. It's not that super important. I'm not telling you it's super important, but if you're doing a lot of performance tuning where you want to go and suggest your developer saying that, boss, can we reduce the toasting? Can we not use the data types? Or uh, last time, okay, let me tell you one thing. Let's extra information. You can make your database or your application in such a way that your big objects are going into some other systems like CDN and another thing. Okay, that you can also suggest. Okay, so let's see. This was my toast table, right? So select to start from. We got it, right? Chunk of data. So basically what happened here, my toast table got created. The furthermore data will come. And if my Postgre is not able to compress that data, cannot accommodate that data into my rows of block, it will toast it. Make sense, everyone?
So
This example is clear?
if the toast table is not created, will it create automatically or
Automatically, no need to do anything. It is completely handled by your Postgre database systems.
And
Never ever
who
handle.
is going to reclaim this toast table? I mean, this toast table going to remain as it is, or any action you have to take by DBA to reclaim that free
Nothing,
space? Those.
nothing.
Okay.
Whenever you are running the vacuuming process, that time only these toast tables will reclaimed. If you have lot of dead tuples, we'll come into that also. Vacuuming and dead tuples, you will understand by that time.
Okay.
But toast is clear.
Yeah.
Abhishek.
Yeah.
So can you again show me the content of that by expanding the display? Like what content falls under PG underscore toast underscore 16597? Just expand the display. No, not this, not this. PG
Okay, got
toast.
it. Got it, got it. So you want to see the select star from that table, right?
Hmm. Yeah,
You
not
will see
this.
lot.
We have already checked this. The PG toast table, which is created automatically from the by the Postgres. Yeah, this one.
Yeah.
So,
Chunk ID, chunk sequence, and chunk data. See here.
so is it
See
like when
this.
you have inserted some millions of
Hmm.
that
Records,
alphabets?
alphabets. Hmm.
So that alphabet, that content
Hmm. Hmm.
cannot be fit in one
Accommodated by
page.
the Postgre block page. It got
So Postgres internally distributed that content into multiple
hmm,
pages,
multiple
and
pages.
when we fetch the data or whenever we select the data for that, that for that content, the Postgres will refer that table to identify where is the data distributed in which all pages.
Yes, I'm just making a small thing for you. So what happens initially? This table row was very big. Initially, it was not able to accommodate that. So it has created the toast table 1. Again, I got the data. I got toast table 2. Okay. So basically, in this 2 KB of space, they have just mentioned the checked ID, check sequence, and metadata of this particular chunk data. So whenever your query will hit this particular object, if the data which is not available in this block, it will go and read this header of the, basically I have made it a little wrong. It's supposed to be here in the header of your block, and automatically after reading the reference, first of all, it will understand that it is a toast blocked. And after reading the metadata, it will go to the correspondent toast tables and you will fetch the data. Make sense?
Okay.
So once compression is done to a certain level, automatically Postgre will see, okay, boss, this room is full, I can't make it. But what I will do, I will say, let's suppose I have a room, this room is full, and this room was having 1 to 100 objects. But now I am planning to insert more objects. So which is practically not possible. So I have created another room. And here I said, boss, if you are looking for bike key and your bike is green, then come and see this particular note. Automatically here you will see all the green bike keys are not in this block. Go to this block. So this is nothing but pointer. So these pointer data is there in your particular toast table, and chunk ID is noted in your main, or you can say father block or the parent block, like that. Make sense? But what
So
is the
Abhishek,
disadvantage of this? Yeah, tell me.
yeah, first you continue, then I will ask my question.
So what is the disadvantage of toasting? The biggest disadvantage. Why I am teaching it? Why I am not skipping this topic? Why
The
this is
retrieval
important?
will be a bit slow.
Very good, very good. Whoever answered, very good. The retrieval is slow. Why is it is slow? Because lookup has increased.
Increase. Yeah.
First of all, I have to look only on one block. Now I have toasted blocks also. Mean to see, previously my stuff was in one room. Now I have to go to this room. Here I will get a note. I will read the note. I will go to this room. This room also I will get a note. Or here also I will get the metadata. I will go to another room, like that. So that's why I was telling, when your code is written, make sure your data types are chosen properly and wisely. Otherwise, Postgre will do a lot of toasting and you will be still scratching your head that why it is slow. So
Okay,
there are
for the
multiple.
DBA
Mhm.
daily active, right? You have to check that how much toast happening on that relation table, right?
No, it's not your work, basically. This is just a concept that you should understand. They should manage their data types in a such a way that it should handled Either if they in certain level, if toasting is happening and a lot of data types has been used, the big blob data types are used, then your data should not be managed on the database itself. It's supposed to go to CDN. That's altogether a different concept.
But as a
Or
DBA, I
it's
need to be
supposed to,
checked, right? This one.
no, when you have a big performance problem, then you can check.
That term only.
Yes, yes, yes. All those things. When you are rewriting your entire database again. So being an architect, you can check all these important things. Okay, can I go ahead? Can we take a small break?
I have one question, so we can
Yeah,
discuss it
tell me.
later also.
Yeah.
Okay, now. So I want to know the difference between this toast data and the large PG underscore large object that we have a system catalog table, right? To store the binary data like blob, lob. So what is the difference between this PG toast and that system table?
What is that? PG
PG
underscore?
underscore large object.
So PG underscore large object. What is today's? I think I have to read about that. What is that? PG underscore large object. No problem. I'll read and I'll confirm you after the class.
Okay. Okay.
So what is your actual question? PG underscore large and
So,
toasting is enabled, like
yeah.
interrelated or something different, right?
Yeah, how different it is. Like you mentioned, like whenever we insert a large amount of data in a single column or
No,
internally that
not
Postgres.
column. The
Yeah,
row,
well,
the block.
yeah,
Yeah.
row. So internally the cell basically. So internally Postgres will divide that piece of information into multiple pages.
Correct.
Because it cannot fit into a single 8 KB pages.
8 KB
So
bit.
toasting comes into picture. So
Yeah,
what
again, one more thing, just add into your concept. Toasting happens only on certain data types, not every data type.
Yeah, like
Okay.
text and all,
Text and all. So
byte text, these all.
text, correct.
So yeah, so then what is the difference? Then what is the use of PG underscore large object system catalog table? Because it also stores, that binary data, like blob data, blob data.
No, it is
So
not.
yeah,
See, PG underscore large object is just a catalog table. It is not storing any data. It is just providing the metadata of large objects as per the documentation. It
no,
is not storing
actually,
it.
right. So one of my customer is using some application, some ticketing tool. So in that, they upload some attachments, Excel, CSV, images, whatever. So the actual database size when we check the table size is 3 GB. When we check the database size is 300 GB.
Correct.
So when we run the system, some commands to check what all things or what all objects have taken the most of the spaces. In that case, I came to know that PG underscore large object is somewhere around taking 297 GB.
Okay.
Yeah. So if the system, if the Postgres only stores the metadata, then how come that metadata became such large that it's storing more than the actual data?
Okay.
So
And what is the version that you are using?
16.8, latest one.
Latest one.
Actually, it's a Patroni setup. We recently upgraded it to 16 version. Earlier, it was I think 14 version. So we upgraded the Patroni as well as this Postgres version. So in that when we then the space size got reduced. When the disk space usage come to 90%, then we did when we do the troubleshooting, then we got to know that the database is actually some 3 GB, 5 GB, 10 GB. But the PG underscore large object, this is the system table which is containing 200 GB, 300 GB, 400 GB. So vacuum LO is the concept when we have to clear the blob vacuum.
Correct.
So when we run a vacuum on a simple table, it will remove the dead tuples, but the large object kind of stuffs remain untouched. So we have a utility of vacuum LO to deal with this, to deal with large object cleanup.
Right.
So yeah, so these all things recently I've done, but
so once you
I'm
run
still
the vacuum,
confused.
this got removed. That might got removed.
So
right?
vacuum LO will remove the link of the blob which is
Metadata.
unreferenced. That means that is not linked to the current data. Like let's suppose you have a data, like you have
Correct.
created
I
one
got
ticket,
it. It got deleted, but still that
but
references
yeah,
exist to
but
that.
but
I
yeah,
got it.
but the reference is there. So these all there are still some confusion. So that's why I asked. So what is the difference between toast and this PG underscore large object? And like how vacuum LO works internally. What is the difference between vacuum LO and vacuum full? So these all things we will I think we will look into maintenance chapter when we study.
Yeah.
So yeah. So my current question is right now my question is what is the difference between toasting and PG underscore large object? Because if it is a system table, then why it is storing such huge amount of data?
Yes, metadata of this. Sure. I'll
Yeah.
find out and I'll just answer you about that also. I just made
Okay.
a note. Okay.
Okay.
Any other question? Anything which is like related? Otherwise, we'll take a short break because today I have to
Abhishek,
cover
just
2 more topics. Yeah.
just
Question is
a
that
question.
yeah, go ahead. Please.
Or can we take it
Yeah,
after
please.
break because people need to take some. Rohit, is that fine?
Yeah, please,
After the break, because let's give
Yeah.
some rest to everyone.
Abhishek, please stop the recording and start the timer.
Yeah.